Welcome, everyone, to this month's edition of Water Data Forum. My name is Max Herzog. I'm with the Cleveland Water Alliance, and it's my great pleasure to have you on here on behalf of the collaborating partners that put on this series, Cleveland Water Alliance, the Water Environment Federation, and the Midwest Big Data Innovation Hub. This is, I believe, now our third year running the forum. We're really interested in engaging you all in a variety of conversations around water and data, demystifying these topics and engaging experts to answer your questions and help sort of paint a picture of what's going on in different areas of work. Today, we're going to ask that you all be submitting your questions via the Q&A function at the bottom of your toolbar there. You may see a chat as well, but we ask that you please submit via Q&A. It allows our panelists to also respond via text during the presentation, so we may answer a few more questions that way. If you do pop your questions into the chat, we will try and get to them, but we will be answering Q&A questions first. My apologies here, I have the wrong title up, but it is my great pleasure to introduce our facilitator for today, Elkin Hernandez. He's the Director of Maintenance Services at DC Water and a member of WEF's Intelligent Water Technology Committee. So with that, I'll ask Elkin to take things away and introduce today's panelists.
Good afternoon, morning for some, and evening for others. First of all, thank you for making time to join us today to this webinar on digital twins. Before anything, before introducing the panelists that we have today, I'd like to make a reference about the term digital twins and how we understand it. So one common understanding of the digital twin is that it's a dynamic digital representation of real-world entities and their behaviors using models and static and dynamic data that will enable insights and interactions to drive actionable and improve outcomes. So just keep in mind that that emphasis on the dynamic data that allow us to take these digital modeling concepts to the next steps. It's important for us to be aware that the concept itself is not new. This concept has been around for decades, and the underlying principles for even longer than decades, but they were not really viable for use in a wider scale before, because we didn't have the massive processing and storage computing power that we have right now. And neither we have the magic of the internet that allows to not only share knowledge, but share data at very high rates. Certainly, in the last few years, couple of decades, and the last few years, we're seeing that the water sector is embracing digital technologies more and more, and with the idea of obviously gaining efficiencies in what we know as the water cycle. This should allow us to improve prediction, preparedness, for the different challenges we have in front of us. It allows process optimization, asset and operational health analysis, and ultimately investment optimization, which is a big concern on the industry. Today, we have a very special panel, and the reason I say that is because we have a very well-rounded set of experts that can help us to go from concepts and fundamentals to implementation and to benefits of the digital twin concept in the water industry. So we have Mr. Mike Carr. Mike Carr is the VP for Global Digital Leader for Water at AECOM. He's also the chairman of the SWAN Americans Alliance. He's been working for several years in this field of digital twins. He has over 2 decades of experience He steers the digital transformation initiatives with AECOM's water sector. His specialty lies in harnessing digital-enabled solutions to boost organizational efficiency, underscored by his depth expertise in smart water, automation, digital twins, and advanced analytics. He's recognized as an industry leader, and he's been consistently at the forefront of digital innovation. His dedication is to the water industry's digital evolution. He will be our first presenter. After him, we're going to have Dr. Pushkar Ragni. He is with Brown and Caldwell, and he is an wastewater innovation leader. He's board certified environmental engineer, named 40 under 40 awardee in 2022 by the American Academy of Environmental Engineers and Scientists. Pushkar is created with pioneering advanced biological nutrient removal technologies. So we have the wastewater treatment expertise here. And he's the author of over 50 peer-reviewed publications that have served as principal investigator for multiple Water Research Foundation projects. He's currently the vice chair of the Web Research and Innovation Symposium and the vice chair of the Web Research and Innovation for strengthening engagement. So certainly what we could call an expert on the water treatment technologies. And the final panelist that we have today will be Dr. Agnete Pedersen. She's a digital twin lead with Van Center SID in Denmark. It's also called BCS in Denmark. This is a utility company, and she has made research about the reliability of the digital twins, especially within the application of the simulation models. She is in the steering committee of the SWAN Interoperable Utility Group, where utilities come together to share a direction of the digitalization of the water sector. So as you can see, we have the different components that would allow us to get a well-rounded view of this topic. With that introduction, I'll let Mike start his presentation. Thank you.
Thank you, Elkin, and welcome everyone. Today's going to be an exciting presentation, and I'm thrilled that you were able to join us today. So just want to start the presentation. So it's an honor to work with Pushkar and Agnete and work with the large team that came together to create a path for intuitive water system operations to guide the industry to apply digital twins. So let's just start off with what digital twin is, some of the benefits. And so digital twin means different things to each person. Elkin was talking about the dynamic nature of how it's critical, and it's critical to us as well. One way to think about it is it's really a common environment that's established to allow utilities to achieve their business goals across the life cycle, whether that's in planning, design, construction, or even operations and maintenance phases. So this holistic perspective across physical and the virtual elements, or the digital elements associated with it, really provide a common knowledge repository for each employee to get a much greater perspective, and each person supporting them, whether it's a contractor, an engineer, or members of the utility itself. And that's been lacking in the industry, and bringing those information systems together and then doing it dynamically is what provides a whole bunch of value to get a lot more information, so decisions and actions are much more well-informed. So let's start with the definition of a digital twin. So we worked really hard over a number of years to have a great amount of debate and discussion around what is the definition of a digital twin. And we partnered not just within SWAN, who is a global organization focused on advancing smart water for utilities in the industry, but also AWWA's digital twin group to come up with this consolidated definition. And I think it's worth reading and highlighting a couple of elements in here. So a digital twin is a dynamic digital representation of real-world entities and their behaviors using models with static and dynamic data that enable insights and interactions to drive actionable and improved outcomes. So the couple of key things within that I just want to discuss for a second is the dynamic digital representation. So that means not just static and legacy data, but that doesn't mean all real-time or near real-time data either. And then the models. So you'll hear a lot of advancements in AI and ML. And we have an immense foundation of mechanistic-oriented models that have been used for hydraulics or biological elements for many, many years. It's really the power of those models and working together that are enabling this new outcome. And then the last part is that the application of this technology has to be done within a way that it's driving the organizational goals forward. And that's done through actions that are creating outcomes. So as we begun as a group within SWAN, defining what a consolidated view of digital twins was, we started getting a lot of critical questions that we spent a good couple of years discussing and debating, evaluating forward-thinking utilities that were implementing them to answer some key questions. One of those questions was, how do I get started? We'll be able to dive into that, and there's guidance in the readiness guide that we'll give a link to in a little bit. So that was a key question that utilities were really struggling. How do I get started within the pressures? Another question was, a lot of utilities were hearing about a revolutionary framework that we provided called the Digital Twin Architecture. And they were wanting specific guidance on how to apply that architecture. And so what we spent that 2 years doing was really take, excuse me, all of the confusion and bring clarity to that, to give specific guidance to all of you and others in the industry of how really tactically to move forward. So that's what the team that brought together to really advance the industry did. And that was over 18 months of specific development on a digital twin readiness guide with over 49 companies participating. We had over 70 meetings and 14 workshops where we developed and matured this readiness guide. So it's with great pleasure that I'm able to give you a screenshot with a QR code that you can scan, where you can download the copy of this readiness guide. And it's freely available for you. You just have to enter in some information into the website to get the guide sent to you. And that guide was really to enable each person to create actionable results that helped optimize performance and better informed your decision making. So I just want to introduce a couple of concepts that Puskar will go a little bit deeper in. But this concept of digital twin maturing over a journey was foundational to the entire guide. And that journey is built upon and advanced by 4 pillars becoming stronger and taller, advancing the organization. And that was really the number of outcomes you're able to provide for the organization, the amount of technology and connectivity that you had between your technology and your humans, the insights that those systems are providing in cooperation with the individuals within each organization, and then the interactions and actions that were enabled by this technology. So those 4 pillars are foundational. They may start small as each journey matures and be built up and advanced over the journey of growing the digital twins within organizations. The other element was really to establish the path of the journey. And after many different analysis, what became clear as the most successful path was deciding a specific and desired outcome that was shared by each organization, and looking somewhat narrow for that early outcome, and then looking for gaps in technology, skills, and organizational readiness for that need to be closed to achieve that outcome. And then you see the little Ferris wheel as the next icon, which is really the incremental development process that is agile in nature of developing a digital twin. And then that unified symbol of expanding the initial digital twin outcome to create exponential benefits for each organization. So this readiness guide was built around 10 case studies from around the globe that focused on these 6 areas of work. So from water network, water treatment, wastewater network, wastewater treatment, urban drainage, and pump station optimization. And I love this quote from a good friend that says, with this, every single drop is under control. And I think that's really exciting to be thinking about the level of maturity that we can achieve with today's available technology. So I just want to have a brief call for your support and engagement. We're all in this journey together of advancing the way we serve our communities. And we have been charting a course together where we've started with maturing the digital twin architecture, coming up with those foundational pillars, evolving and tuning and refining the journey that each organization takes to implementing digital twins, releasing the readiness guide, and we're really excited to continue and accelerate that growth across really the entire industry. And please reach out if you want to get involved, make your mark on the industry and really contribute back to your communities. Our contact info will be at the end. Please reach out. We'd love to have you join us along this. With that, I'll turn it over to my good friend Puskar and dive into his presentation. Go ahead, Puskar.
Thank you, Michael. So before we get started here with my section of the presentation, I just want to start with a global perspective here, right? And the global perspective here is, there are like 2.4 billion people without access to sanitation, and there are additional 70 million people who lack, clean drinking water, right? So this is the context that we have. And I don't think digital innovation is kind of an option. At this point, it's kind of a necessity if we want to address these global challenges, right? So let's go to the next slide. So I think in general, the modern utility landscape and the modern utilities, they do understand the importance of digital transformation. And they are, willing to take steps in the directions of digital twin in terms of like revolutionizing utilities and how can we do more with less concepts. So the intention is there, but as you would see, the steps required to get there is still lacking, right? So that is one of the utility kind of a concept here, with intention being there, not having clear direction. So let's go to the next slide. And when it comes to like digital twin, it sounds, the promise of digital twin, the benefits are there, right? But it also comes with a lot challenges, and challenges that could be new to a utility. These are like complex systems. There is no clear guidelines. Daily operation takes a lot of toll, and to focus on something innovative and requires like different set of like skills is always going to be a hard thing. And there is a question of, how do you keep up with the changing landscape of rapidly evolving digital technologies, right? And how do you find the time as an organization to allocate? So these are the main challenges that we have. But the good news here, go to the next slide, is that we had made some progress in terms of getting started, right? And Michael briefly introduced the Digital Twin Readiness Guide. And I think it's a kind of an important resource which outlines how can you get started for successful adoption, and how can you draw some of the insights that has happened, some of the early wins across the world with the case studies. How can you borrow some of those concepts and implement yourself in your utility, right? So with that, I would like to give you, let's go to the next slide, the journey of creating this Digital Twin Readiness Guide. We had a very clear mission in mind. We wanted to build a common language so that we can have a conversation like this. And we also wanted to align the water industry ecosystem around these common language and common architecture, right? And also we wanted to answer some of the pressing questions around implementation, things like why does utility need a digital twin? Where do I start? How do I apply the digital twin architecture and things like that, right? So it had a very clear mission, and I think we were quite successful in getting there. And it was all possible because of, let's go to the next slide, of all the people coming together, right? So we didn't do this in isolation. We had a broad spectrum of people who informed this readiness guide, from academics to utility managers, consultants, and technology providers. They all shaped these concepts that are included in the guide. I think they are very powerful in that regard and kind of captures the broader perspective of the industry. Let's go to the next slide. And when we started working on this readiness guide, one of the first things that we wanted to tackle was how digital twins are like different from conventional models. Everybody who has done like design of big systems, they have used models, they're familiar with it. But what does, what makes that digital twin different from some of the conventional modeling concepts that we already have, right? And it comes down to, using the real-time data, and which is continuously updating. These models are generating insights which are real-time, which are automatically updating. And as the result, you get like real-time insights and actionable results, right? So that is the differentiating element of digital twin versus some of the static concepts of conventional model. Let's go to the next slide. And Michael already brought up this, digital twin architecture, but the way that I want to kind of visualize this is that you already have a physical system, right? Like most of the utilities, they have the physical system, both on the, infrastructure side and the digital side. The digital twin component comes into play when you start like gathering information, gathering data, analyzing them, visualizing them, and at the end of the day, creating some sort of user experience where you gather insights which can help you, create like informed decisions, optimize performance, and actionable results. If we are not closing the loop with these actionable results, it's not a digital twin. It's maybe a digital twin in the making. You may have parts and components of a digital twin, and maybe you are in the right direction, but you have not achieved digital twin. So closing this loop with actionable results is a critical kind of a thing. And at the end of the day, once you start doing this, the benefits will, kind of propel, using these concepts more and more, and you'll get like more into implementing this at a wider scale within your utility. All right, let's go to the next slide. And Michael already showed this journey, but the thing that I want to highlight here is, every utility is in a different place when it comes to their digital twin journey, right? But these simple concepts of identifying what you need to achieve have a very much clear, objectives in mind. Then moving on to assessing, the key questions that you have, and also what are the key, gaps you have in your technology, what you already possess in terms of skill sets, and infrastructure in place, is an important couple of steps. And then you go into this implementation phase, which is kind of underscored by the iterative nature of implementation, right? And it could be a little bit different. We are used to designing systems that last for like 50 years. The design needs to be perfect. Otherwise, we are gonna, miss our permit or something like that, right? But here, with the digital twin implementation, it's an agile kind of implementation. You can make some mistakes, but you can learn from them and keep making progress, right? So that's the idea. And once you get comfortable with some of the small wins, then you expand and add like more capabilities, and you try to do this system wide, right? And as you start like expanding this, the benefits and the return on investment will get more attractive, right? And that's gonna fuel this initiative, and moving forward, right? So that's the idea with the digital twin journey. Obviously, Michael went through some of the pillars that support this journey, but at the end of the day, you just have to do it to get the experience and get into it. So let's go to the next slide. So the 10 case studies Michael highlighted, I think they're very important in the sense that these are like some of the early success stories that we have from across the world. They represent different parts of our water system. But at the same time, the way that we have included these case studies, they all use digital twin architecture. So it makes you a little bit easy to kind of follow along. But at the same time, they give you enough insights to apply in your own utility scale, right? And these are, again, capture some of the wastewater, water network, urban drainage aspects of our water system. Let's go to the next slide. I've been thinking about this for a while now, based on some of the activities that are happening in our industry, some of the RFPs that we see on the digital space that is coming out. And it seems like there are 4 stages of the utilities that we have. And the first stage is, you have a process, but on the digital side, you are still need to build it up. You need to develop your infrastructure. The infrastructure is not quite there yet, right? And then there is a second stage, the intermediate stage, where you have the digital infrastructure maybe, but there are some of the technological augmentation that is still needed, right? And if you have gone past that, if you are advanced stage, then you want to be aligned on how to use these, technologies that you have, the digital infrastructure that you have, right? And then finally, if you are strategically aligned, you can be thinking of doing continuous optimization, and this is what we can call optimized stage, right? And where you would start leveraging the concepts of digital twin and leverage like digital transformation within your organization. Let's go to that next slide. And the good news is, if you look at the industry right now, despite some of the struggles with hiring resources, those still persist. But it seems like there is a positive trend towards optimism of digital technologies like AI. The concern is decreasing, and with this sort of like a kind of a landscape where more and more people are warming up to the ideas of leveraging digital technologies on their daily day-to-day work life, maybe the adoption of digital twin will also benefit quite a bit, right? So this is a positive, kind of a development in recent times, and that will help with utilities poised to make these changes within their organizations. And finally, Next slide. Finally, I want to kind of share this example of a progressive utility who I would call them like almost stage 4, optimized stage, continuous improvement, where they believe they have invested enough in terms of digital infrastructure and digital tools. Now they are ready to start looking at digital tools to support their real-time decision support, harness like power of the data, and leverage like advanced automation throughout the processes, right? And in the process, what they want to achieve is to lay the foundation for digital twin so that they can do this at a large scale. And we see this as the utilities progress in this journey. Some of the questions that they're asking is going to get more ambitious. And talking about like progressive utilities, I think we have a excellent kind of presentation from Agnet, who is going to talk about their experiences in doing digital twin in Europe. And with that, I'd like to pass it to Agnet.
Yes, and thank you that you want to have me to speak at this to the audience here. I am from VCS Denmark, which are a smaller utility, but we are the third largest city in Denmark, but we are a smaller utility compared to the US, I guess, with about 230,000 inhabitants in the two municipalities that we are servicing in our area, in our company. I recently did a PhD in digital twins and these simulation models, if we could try to look into if we can replicate the reality in the simulation models, and that's also what this presentation will be about. Yes, so in our utility company, we have the waterworks distributions, we have the urban drainage system, and we have also water resource recovery facilities. But in this presentation, I will only talk about the urban drainage system. And in that system, we have a lot of sensors. And we also have a fairly good hydraulic model, which we applied, or which we are applying for a lot of design purposes, and also to give updates to the municipality, what happened during the year, how many overflows did we have, and so on. So we use these models for a lot of things. But one of the questions, because I'm working in this industry for a decade now, and one of the questions I had, and I also asked in my PhD, is how good are these models to replicate the reality? Because we have a lot of puzzle pieces, like attributes, the asset database, the surface descriptions, and we also have puzzle pieces in the models and observation and in these analysis and updating tools. And all of these puzzles, we are trying to replicate the reality, but do we see the full picture? That was one of my questions. And that's what is the purpose of this digital twin, is can we evaluate how good is the model? We actually started in 2008 doing a daily comparison of the model and with the observations. So we have been doing this for a long time, but it's first into the last 5 years that we actually systemized this a lot, and I will show you in this presentation how we did it. So we used, we can follow this architecture, which is made by this SWAN group. And I will show you here how we did it, because we have the asset database, which are this data collection and sources. And from here, we can extract the data from the database, put it into this model building updating tool that we have in Denmark. And we can also put in a lot of analytics about the model of the surface, model of infiltration and water loads. We can put this into these this updating tool. And from this updating tool, we can extract an operational model of our entire system, or actually we can also extract design models and planning models. But for this presentation, I will focus on the operation model, because we extract an operation model And all of this, we are updating this regularly, not day to day, but regularly, maybe every third month or so. And this is the static data in the terms that Michael talked about. And then we have the more dynamic data where we have the sensing and control and the data collection sources. This is the boxes from here, where we have the interim sensors, the permanent sensors, and all of our rain gauges and radar in this area. And all of this we integrate into our data storage, where we can extract these data and do some analytics. The data quality control, we can make soft sensors, and we can also make this aerodynamics and model evaluation, which I will be talking about. And everything we can put into a visualization platform, and then we can make action through this visualization and see what happens, what needs to be changed. If we see that the model is not behaving as it should, can we find the reason for that and then change the model, and then it will hopefully be better the next day. One thing that I want to show or say is that there is not only one provider of this, and there's not only one platform, and that is especially important for us in the utility company, because we would like to see this as a puzzle pieces, or like a big puzzle, and we need to change this puzzle, the one puzzle pieces that do not match into this picture, or if something happens, we are not relying on only one provider. We will rely on a lot. It requires a lot of ownership from us, but we are willing to do this because we think we can become more flexible, and we can also put in new providers that has a good solution. Then we can change some of the puzzle pieces. So that is especially important for us. Then I would like to show you some of the results, because that may be interesting. And we thought that when we do this model evaluation, it's always easy to see it graphically just with a traffic light. So if it's red, it's not as good, and green is better. And then there is some details about hatch and all that stuff, but I will not go into detail with that. But also to say that I have made two plots, and one is for everyday events when it's raining just a minor amount, and then the situations where we have an overflow occurring. And that's the differentiation in what you are looking at is not something that we in the community have been really good at. We are just saying we have a model for everything, but what is it really good at? And we are mostly using our models to design the network, and that is especially in the overflow, but actually our model actually performs better in the everyday events. Yeah, so that is not surprisingly, but just it also realized a lot that we need to be better at looking at these particular overflow events, for example, seeing if we can optimize the model. And then you can ask, why don't you just calibrate the model? Then it will fit. But I have written an entire paper about this, and if you're willing to or interested, you can read about it. But we would like to make this aerodynamic instead, and say, okay, what is wrong with the model? Because there are so many places in a model that you can be wrong. So it's not only the parameters where you typically calibrate, it can also be in just the understanding of some of the model tools that you don't understand, and maybe you should look into understanding the model, or maybe it's the physical attributes that simply, or the system attributes that are wrong, or maybe it's the rain that is falling different in the area or something. But I could talk forever about this. Yes. So this is just an example. The fevers were from my PhD, and now I have implemented all of this into our system. And this is also the table is from my PhD, where I tried to summarize how many sensors we had. And at that time, we had around 350 SCADA systems, and now we have a total of plus 400 sites. Actually, that's the 26 that you, no, 270 that you need to compare. So we are expanding our sensors rapidly, and we are putting sensors everywhere, and we need to look into these sensors and trying to automate some of the analytics that we do, and that's what I'm trying to do. So we don't just have a data graveyard, but we actually also are using these data. And just to show this tool that we have, the visualization that I can just plot, this is the model with the dark blue and the observations with the light blue. And then I can visualize all of these data with the time series. And then I can also get, this is not quite finished yet, but I can make these analyses of how good is my model performance like I did before from these case studies. Then I just tried here from the overflow, and it's only based on 1.5 years of data. So I don't have that many overflow events. So it's kind of red, and there's also some things that I need to check. But that's the purpose, is that we get a map, and when I are going to design something new, I can look at this map and say, okay, can I trust my model before I even start doing some simulations in this area? So this was my model evaluation, and what to do now, because we have so many data in the cloud now in our data storage. So now we are progressing doing different stuff. So we have started up doing anomaly detection, both being proactive. How can we prevent that that we need to go do maintenance in the weekends and during the weekdays, and also if something happens, if there's a system anomaly, how do we become aware of this quite soon, instead of maybe seeing it firstly Monday or Tuesday or something. We also use this simply as an awareness tools of where do we have sensors, because they're really costly, and if some of our operational staff are not aware that there is a sensor in this manhole, then they can destroy it. So this we are also using these tools for, and we make these overflow reports instead of having them doing annually. Then we can have them what happened in the weekend, how much overflow do we have. We have cloudburst alarms for faster information knowledge to our customer care and the project managers that we have. If there is a cloudburst, then they can inform the customers. And we can also easily extract these complex data, which are often hidden somewhere in some SCADA system. And we can now easily extract this and give it out to the external people that we have working for us. And one important thing to say is that we are having a lot of collaboration internal, and we are also a lot of departments supporting this digital transformation and the digital twin. And it is important for me that all of these departments that are contributing with information to the system also gain knowledge from this system, because then they are aware that the information they give, and if there is a failure, if there's something misunderstanding, then they report it, and then they actually get a better results back. So I think that's especially important when you're a utility company and you need to collaborate with all your colleagues. Yeah. So that was everything for me. Oh yeah, sorry, I have one slide. If you want the papers, then you can find them here.
Well, thank you, Agnir. Thank you for the great presentation. Now I'm gonna switch into, we have about 10, 40 minutes for a Q&A session. So please feel free to send your questions using the Q&A tool on Zoom. And I will myself try to moderate these questions. And we have a couple, so let me do something here. And the first question we have is a very interesting one. It says that one of the barriers for the adoption of digital twins is the cost of software, sensors, and talent. So If anybody here can help us describe what is the vision and experience of making technology affordable to utilities.
I have some thoughts on that. So, in terms of the software, sensors, some of the technology behind it, I think the cost curves for those are like, favorable. The cost is declining overall for the industry. But I think the talent is something that is going to be a big deal, right? Like, how do you address the talent issue? Because if you think about talent, especially on the digital side of things, it's the same talent that is used by tech companies, and it's going to be hard to get those resources working for like water industry just based on some of the pay gaps that we have, right? So I think one of the ways to address that issue is training programs, collaboration between like utilities in terms of training and grooming like people, and educating them, grooming these individuals like within utilities, as opposed to hiring like 100% from the outside. There is always going to be a blend of like what you bring from outside, but also I think grooming needs to be a big part of that. So that's my kind of high level thought. Maybe others have other ideas.
I have one comment.
Go ahead, please.
Yeah, because that's also one of my concerns, because I'm a utility company and it is expensive to do all of these solutions and to do this digital transformation. It is just expensive. But what we are working on with the interoperability utility group that I'm also in within SWAN is that we are trying to figure out how can we help each other. So whatever being developed in Australia, I can use it in Denmark and vice versa. So we are not alone in this transformation, and that also smaller utility companies can join this, not having the big engine running, but maybe only smaller parts, but it's still running. So how can we make a system that is not only for big utilities with a lot of money, but also for smaller utility companies that can afford the small solution of a digital twin?
Thank you. And I would think that plays along with your comments on trying to make sure there's not just one solution for everything, but there are different boxes that can be exchanged and fit according to the needs and the means of the different utilities. So thank you for that comment. I have a couple of more questions. One is very interesting. It says how we foresee the environmental impact of using a digital twin. Building and maintaining the infrastructure necessary for digital twins can have environmental consequences, including increased energy consumption, electronic waste, and ultimately, how are we thinking to control the carbon footprint due to digital twins? Considering the climate change do we think is sustainable in the long term? So that's an interesting question that anybody wants to give it a try.
I'll start. So I think this question is about, more the computing impact of digital twins, and the trade-offs associated with that. So there's quite extensive opportunity within utilities to reduce the impact of energy, climate, carbon, etc. And some of the best ways are leveraging these type of technologies that require more computer and intensive computing resources. So you have to be confident, which I think we are, that leveraging that computing resourcing power is a net benefit to the application of it. So when you leverage digital twins, it does require more computing resources, but the benefit of optimizing energy, chemical, carbon footprint, even analyzing the maintenance worker route history and service patterns reduces the amount of time on the road to achieving maintenance input. So that's one element. Another element is data center optimization of how they're placed, cooled, energy. That focus is a little bit outside of the discussion of the digital twin, but I know there's quite a bit of research and advancement in those areas as well.
I
Don't
think
know if I got the question completely right, but
no, I think it was an interesting question and bit open, but I would agree that process optimization, the optimization that technology can facilitate to a utility, very likely, if it's properly executed, should be in excess of whatever negative impact it brings, right? So the savings, as you mentioned, chemical, the carbon footprint from transportation, when you have less chemicals, it's not only the production, the transportation, production of biosolids and the like, should be enough to cover those savings, those needs.
I have one follow-up on that, if I may. So even if we say like there is a net positive of digital twin, regardless of all the, some of these consequences, environmental consequences that it may have, there's a net positive in terms of like efficiencies gained, reduction in energy, chemicals, and everything in between. At the end of the day, I think one of the philosophies that we have to follow is that if it goes back to like identifying your objectives, for the sake of doing digital twin or, adding like more infrastructure, we shouldn't be doing that. We have to be critical in terms of our objectives, what we are trying to solve, and align everything based on that. Having like more than what is needed is never a good idea. It creates like, more confusion in terms of like maintaining them and to sustain them, right? So not only it's a hassle from a perspective of like maintaining them, it's not good for the environment as well. So we have to be critical and go back to like what we are trying to achieve.
Thank you. We have a couple of other questions on the board. One says, for a mature facility that already had its own control monitoring software platform, how the external modeling software can be integrated into? Does everything have to be redeveloped in order to be compatible, or can we reuse some of that existing infrastructure?
Agneta, do you want to start off?
Sorry,
Yeah.
I was trying to also text something. I think that that we would like to see that we can set up some standards for the input and output from different tools, so that that's something we're trying now, that we have a data standard for all utilities, that this is the standard of our asset database or our pumps, how they provide data. But it also requires that the software develops are for the different, maybe there is one company who are really good at doing data analytics or data cleaning or whatever you can this tool can do, but it requires that we also get the output standardized from this, so the next step or the next puzzle pieces know exactly, okay, this is the output from this tool, whichever company do this tool, and then the next tool can make it. But it requires that we as a community talk a lot together and also agree on what is the different standards, so that we can develop on each other instead of all are doing data cleaning, because everyone needs to do that. Maybe one or two company or a standard can say, okay, this is what a cleaning do, and then this is the output, next step, and then we can progress a lot more.
Thank you.
Yeah.
And I have one follow-up on that, if I may, just
ahead,
to, so on the data collection side of things, I think, data is data. Whatever external modeling software that we are using should be able to utilize the data without the need to change anything in place, right? So that should be one of your selection criteria of the modeling software, that you should be changing what you are collecting already. Like it should not result in changes in your data collection and monitoring, infrastructure, right? So that's one of the criteria that you have to follow. Otherwise, it's you're not only having a new platform for modeling, you're also changing everything that you knew. That's not a good, that's not an easy place to be, right? So.
think we're running out of time. I think there's a question that came on the chat, so I'll see if we can go quickly over that one. It's for Unit, and it talks about the characteristic of the SCADA, HMI, and historian that she's using, and how is she fusing together with the other systems. Maybe you can quickly try to summarize it.
I cannot see this question.
It's on the chat.
Sorry, just yeah.
That's fine. That's fine.
Okay.
That's okay. Good. Thanks for giving it a try. So I think we're coming to an end. We have only a couple of minutes. What I want to use this time for is to remind everybody that this series is going to be recorded and is going to be posted and available for everybody to watch later, share with other people. This is the Water Data Forum. This is a joint initiative with the Cleveland Water Alliance, with the Water Data Forum, with the Midwest Big Data Hub and the Water Environment Federation. We've been working together for the now almost 3 years on this series, and we intend to continue. In November, we have a new session coming. It's titled Toward a Resilient Future, Managing the Impact of Changing Climate on Community Infrastructure. So it's a topic that is well current and of great interest for the communities and for the policymakers. So hopefully you guys can join us during that for that presentation. And with that said, I say thank you for the panelists, for your time, for sharing the expertise. The contact information I think has been shared for some of them. So please, if you have any follow-up questions, follow directly with them or with the information for the Water Data Forum. Thank you, and have a wonderful rest of the day.